Video, we are going to be reviewing conic sections. If you've never learned about conic sections, I would highly suggest that you find another video that introduces these topics from the beginning. So for review, a conic section is formed by the intersection of a place and a double napped, a plane and a double napped right cone. A double napped cone is two cones opposite of each other, extending infinitely upward and downward. The angle of the plane creates the type of conic sections. Label each conic section below. So when our plane goes straight across our cone, it creates a circular section, so a circle. When it cuts at a diagonal, such as we see here, it creates an oval-like shape, which we call an ellipse. When it cuts at a diagonal and goes through the bottom of the cone more so, it is called a parabola. And when it cuts through the cone, opening both up and down through the top and bottom, we call it a hyperbola. For the focus of this video, we're going to be reviewing circles and ellipses. For circles, the standard form of an equation of a circle is the equation, parentheses, x minus h, quantity squared, plus y minus k, quantity squared, equals r squared, where h comma k is the center and r is the radius. In conic sections, we have something called a locus. So all conics have a locus, or a set of points that satisfy a certain condition. For a circle, the locus is all points that are equidistant from the center. Let's go ahead and look at some examples of how to graph and write the equations of circles. For problems 1 and 2, it says, if necessary, write the equation in standard form, then graph. For problem 1, our equation is not currently in standard form because it's being multiplied by 3 in front of x and y. To get our equation in standard form, we're going to divide all terms by 3. This gives us x squared plus y squared equals 64. Now we're going to identify our center and radius. Our center would be the value in here subtracted with x. Since we don't see anything, that value is 0, and the same for y. The number that's on its own side of the equal sign is our radius squared. So if r squared is equal to 64, so our radius must be equal to 8. So now to graph this, I'm going to plot my center, which is at 0. I'm going to go up 8 units, down 8 units, right 8 units, and left 8 units. And there's our sketch. Let's take a look at the next example. For our next example, our equation is already in standard form. Our value h comes from our x, and it's always minus, so our center is at 1, comma, positive 2. And our radius squared is equal to 25, so our radius must equal 5. So now we can go ahead and sketch our graph using the same method. We're going to go to our center, right 1, up 2. And then from our center, we're going to go up 5, down 5, right 5, and left 5. And there is the sketch of our graph. For our next example, we're going to look at how to write the equation in standard form and then identify its radius and center. When we write an equation in standard form, we want to have x and y on the same side and our number on its own side. So that's what we're going to do to start. We already have x minus 4 quantity squared on the left side, so I'm going to add y squared to both sides, which would give us plus y squared minus 52 equals 2. Then I'm going to move the 52 to the other side. So we have x minus 4 quantity squared plus y squared equals 54. Now that our x and our y are on the same side being squared and our number on its own side, this is in standard form. In this case, our center would be at 4, comma, 0, since nothing is here with the y. Our radius is our radius squared equals 54. So our radius would be the square root of 54. Which we can simplify this radical to be 3 radical 6. Let's take a look at the next example. Once again, we want to start by getting our number on its own side of the equation. And we want to group our x's and our y's together. So we're going to have x squared plus 6x plus y squared plus 2y. And I'm going to move the 6 to the other side by doing minus 6, so equals negative 6. I left these spaces here for a reason. What we're going to be doing next is something called completing the square. If you haven't completed the square or you don't remember completing the square, I would suggest pausing this video and watching one that shows you. When completing the square, our goal is to be able to write this as x with something in here, quantity squared. So based on the number we have here of 6, if this was squared, 6x would have been made by adding 3x plus 3x together, which means that 3 would have been our number at the end. If we square that, we would have plus 9 here. So when we rewrite this in factored form, it'd be x plus 3 quantity squared. However, we can't just add a value into our equation without adding that value to the other side to keep it balanced. So if I add 9 here, I add 9 on the right side. We're going to do the same thing with our y values. Our goal is to write this as y plus something quantity squared. We have 2y here. That resulted from y plus y, which meant that we had a 1 in the front. When we square 1, we get 1. So plus 1 here, and plus 1 on the other side as well. Y squared plus 2y plus 1 factors into y plus 1 quantity squared. When we simplify the right side of our equation, we have 10 take away 6, which is 4. Now this is in standard form. Our center is negative 3, comma, negative 1, since these are positive values now and they're typically minus. And our radius would be 2, since our radius squared is 4. Let's take a look now at ellipses. An ellipse is the locus of points such that the sum of the distances from any point on the ellipse to two fixed points remains constant. These fixed points are called foci, or foci. You may hear different pronunciations of the ellipse. So in an ellipse, the defining thing about it is that this distance from one focus to the outside of our ellipse plus the distance from the point on the outside to the other focus will always remain the same. So d1 plus d2 remains constant for all points on the ellipse. Let's go ahead and define some common vocabulary that's used when describing an ellipse. The first word that we're going to define is the major axis. The major axis is the larger axis and contains the foci. So on our diagram off to the left here, the major axis would be the one that is running from left to right in blue here. With our major axis, we have our vertices, or each of them is a vertex. Vertices is plural, so those are at the end of our major axis. Then we have our minor axis. It is the shorter of the two axes. And at the end of those, the axis on the ellipse is where we have our covertices. The point where our two axes intersect, we call the center. So right there. We have two types of ellipses that we're going to be looking at. We have horizontal ellipses and vertical ellipses. So just to do a little vocabulary refresh there, this point here would be a vertice because it's on our vertex because it's on our major axis. These would be our foci. This is our center, and this is our covertice because it's on our minor axis. We could do the same here. So we say that our vertices, so the points would be here and here, are plus or minus a units away from our center. So this would be A, this would be A, this is our center. Our covertices we call plus or minus B units away from our center. So this would be B, and this would be B. The length of our major axis would then be 2a because we have a plus a, and the length of our minor axis would be 2b. We say that our foci are c units away from the center. So this length, this is our focus. We call this length here c. We can do the formula c squared equals a squared minus b squared. We're not going to go over where this formula comes from in this video. Our standard form for an ellipse is x minus h quantity squared over a squared. This would be if our ellipse is more horizontal, plus y minus k quantity squared over b squared equals 1. If our ellipse goes more vertical, the part that changes is a and b, because a represents the longer length. So we would have x minus h quantity squared over b squared, so now our x dimension is smaller, plus y minus k quantity squared over a squared equals 1. Let's go ahead and look at how are we going to graph an ellipse. When graphing an ellipse, we want to start by writing the equation in standard form if it's not already. Then we want to locate the center, vertices, co-vertices, and the foci. Let's go ahead and look at example 5 to try that. Since this ellipse already has x squared over a number plus y squared over a number equals 1, it's in standard form. Since there's no value being added or subtracted with our x and y, this tells us that our center is at 0, 0. To find our vertices, we're first going to look at the number here that is bigger, because that is going to be our longer axis and our major axis, so 64. So what we know is that this number here is our a squared value. So a squared equals 64, so a must equal 8. That means that from our center, our graph is going to go to the right 8 units and left 8 units. So if we take our center and we add 8 to our x value, that would be 8, 0. And we subtract 8, it would be negative 8, 0. Let's start by plotting these. So we have 0, 0. We're going 8 to the right and 8 to the left. Now we need to find our co-vertices. To find our co-vertices, we look at the smaller number. So in this case, 25. So b squared equals 25, which means b equals plus or minus 5. And this also is plus or minus 8. Sorry about that. So that means we're going to be looking at going 5 up and 5 down from our center. So from our center, we're going to go ahead and add 5 to our y and subtract 5 from our y. So it would be 0, 5 and 0, negative 5. So let's go ahead and plot those. The last thing that we need to do is find our foci. So to do that, we're going to use c squared equals a squared minus b squared. C squared is what we're trying to find. A squared is our bigger value here, so 64. B squared is the smaller one, so minus 25. When we subtract those, we get c squared equal to 39. So c equals the square plus or minus the square root of 39, which is approximately plus or minus 6.24. So from our center, we're going to add 6.24 and subtract 6.24 to our x, since this has its major axis going horizontally, to find our foci. So it's going to be negative 6.24, 0, and positive 6.24, 0, which are approximately here and here. Now we can go ahead and connect our vertices to form, and our co-vertices to form our ellipse. And there we have it. Let's look at an example where we have to write the equation when we're given the diagram. So in this case, we can start by drawing in our major and minor axes. So our major axis is going horizontally, and our minor axis is going vertically. The point where they intersect is going to be our center. So it looks like we have a center at -1, 2. We can also identify our vertices. In this case, we have a vertex at 6, 2, and -8, 2. The important thing we want to take away here is how long is it from our center to each vertex. 1, 2, 3, 4, 5, 6, 7. So our A value is going to equal 7. We can do the same with our covertices. Our covertices are located at 5, -1, 5, and -1, -1. From our center, it goes up 3 or down 3 to create our B value. So B equals ±3. We really don't need to find our foci to write our equation, so I'm actually not going to do that. To go ahead and write our equation now, we're going to say that we have x minus our center, which in this case our center was -1, so it becomes +1, quantity squared over, since our major axis is on our x, it's going to be over a squared here. So 7 squared is 49. Plus y minus our k value, which in this case is 2, quantity squared over our b value, which is 3. So 3 squared is 9, and that's going to equal 1. Let's take a look at 2 more examples of writing the equation of an ellipse in standard form. To write the equation of an ellipse in standard form, we're going to use some of the skills that we use to write the equation of a circle in standard form. First thing that we're going to do is get all of our x's together. We're going to have 4x squared plus 24x. We'll leave a space here, plus y squared equals 28. When we think about our standard form of an ellipse, there's no coefficient, the coefficient for x is a 1, so we want to get that happening here. So we're going to factor a 4 out, which leaves us x squared plus 6x. Now we're going to complete the square similar to what we did for a circle. So if we have 6x here, that means we had 3x plus 3x. So the coefficient was 3. When we square that, we would have plus 9. Plus y squared gets to stay the same because it doesn't have any y values being added here, equals 28. Now we have to remember that we have to add to our right side of our equation because we added a value in here. We really added 4 times 9, so we really added 36. Now we can write this as 4 times the quantity x plus 3 squared plus y squared equals 64. Now remember, when we have our equation, we want it to equal 1, so we're going to divide everything by 64. Here, our 4 and our 64 simplify. We can rewrite this as x plus 3 quantity squared over 16 plus y squared over 64 equals 1. And now our ellipse is in standard form. Let's look at one more example together. Once again, we're going to group our x's and y's together. We're going to get 9x squared minus 36x, and we'll leave a space here, plus y squared plus 10y, and we'll go ahead and move that 52 to the other side so it's not in the way as we try and do our difference or our completing the square. So minus 52, so equals negative 52. We can go ahead and factor out a 9, which leaves us x squared minus 4x. To complete our square, we know that this came from doing minus 2x plus negative 2x. So that means we had a minus 2, which got squared, which would have been plus 4 here. Our y already has a coefficient of 1, so we're going to say plus y squared plus 10y. And the 10y came from doing 5y plus 5y, which means we had a 5, and 5 squared is plus 25. Now don't forget, we have to add some stuff to the right side of our equation. For our x, we have to do 9 times 4, so plus 36. And for our y, 1 times 25, or plus 25. Now we can write this as 9 times the quantity x minus 2 squared. It's minus because our middle term is a minus, plus y plus 5 squared equals, when we add all these together, we get 9. In our last step, we want to make this side a 1, so we divide everything by 9. So our first term ends up being x minus 2 quantity squared plus y plus 5 squared over 9 equals 1. I hope this video has helped you review circles and ellipses and conic sections. Thanks for tuning in.